All right, thanks a lot. Can everybody hear me? Yes. All right, then I won't talk any louder than this. Okay, so as mentioned, I'm a professor. I teach a lot of different things. I'm very passionate about education. Actually, if you like education, here's a nice, easy read. It's about a 100-and-something page book by John Seely Brown and Douglas Thomas. And it really talks about this idea that in the beginning, you got to figure out what it is you want to know. Right? Like I need to know about Python or JavaScript, right? But as soon as you can, you want to get to where you get to start making things, right? And that's one of the things I love about Python. It's so easy to get started quickly and just start building something. But then that next step, which is a little bit more contentious here in Asia, is you want to get to that point that it's fun, that you can just start playing, right? So in the beginning, if you're an architect, you want to learn how to build a building that doesn't fall down. Right? But after that, you want to get to where you can start making a building that's a little bit cool, right? Something like the Esplanade, or can we build 3 buildings and put a boat on top of them, right? And make a landmark, right? And so when it comes to coding, it's that same thing, right? Build something that doesn't fall down, and then get enough confidence that you can start taking some risks. So I teach a lot of different types of courses. I teach like 2 major undergrad courses in software engineering and cloud computing. I teach a master's course in big data analytics. But I also teach these 3-day courses. Now the 3-day courses are very different than the university courses, because university courses, I get to assign homework, I get to give really hard concepts and give people a week to go back and think about them, right? But when I have 3 days, 24 hours of coursework, I'm trying to cover a lot of the same material, but no one will do homework. And in fact, when they leave at 5, they don't even think about things till they come back the next morning, right? So it makes my class time much more valuable, and it makes that learning in class really, really important. So that's something I spend a lot of time thinking about. So I'm a big believer in this idea of flow. The idea that no matter what speed I go, some of you I've already bored and you're looking at your email, right? Waiting for the code to appear. Others of you, it's like, what is he talking about, right? And maybe I've already lost you. And no matter how hard I try in a class of 40+ students, I'm always frustrating some and I'm boring other people. And that's okay. I don't expect to get 100%. All I can hope to do is move as many people through this flow channel as possible. And the trick to that for me is I've got to always be adjusting my class to, to my teaching style to adjust to the class. Okay, so for me, I think of this just the same way that game designers do. If the game is too hard, you'll get frustrated and you'll quit, right? If the game is boring, you'll get bored and you'll go find another game. There's always Angry Birds Space, Angry Birds Rio, whatever. My course is the same way. If you don't like my course, you'll study for another course more than mine, right? Or you'll study as little as possible and then you'll go off and play more Angry Birds. Right? So I have to go after a lot of the same things that the game designers do. I have to have clear goals, opportunities to concentrate, achievable tasks, this immediate feedback, and eventually I want you to get into this deep, effortless involvement, right? Where you're just starting to play, you're starting to build things, and you lose track of time, right? Have you ever looked up after coding for 3 hours and go, wow, where did the time go? I mean, I know I've lost track of time, and I know it's been a long time because my back is hurting something, or I need some circulation. Okay, so that's sort of the way I go. So my wife did this great thing for me when I first started teaching, is she went off and made me these nice little games. Because I told her, I can't tell who's lost and who's bored, right? And when they are lost, I don't know what to throw at them to help them sort of catch up on their own. So she built this nice little drag and drop game on SyncPath that lets kids in high school use this a lot here in Singapore. And the kids will go out and you're just dragging lines of Python code and assembling a solution that solves some problems. And for kids, it's great because they don't even think of this as programming. It's just a puzzle game, right, for them, and anybody can do it. But what's interesting is after you solve about 100 problems like this, you still may not know how to write Python, but you know how to read Python. And when somebody puts some Python code in front of you, it's not nearly as intimidating. So for high school students and even some of my students who don't love coding, they're just taking the course because they have to, because they joined a school of information systems. So yes, programming's part of it. We'll give them badges. We'll give them, clear feedback. Here's how many problems are available and how many you've done. We'll have rankings. Just want to let people, whatever motivates you to spend 5 more minutes practicing your Python or your JavaScript and 5 minutes less on Angry Birds, that's a win, right? Okay, so we'll do that. Now, eventually, though, you get hit with the big text box, right? And just like writers have trouble with writer's block starting that first novel, for me as a software developer and also for my students, that hardest part is just opening the editor, right? That getting started. And it's very intimidating to a beginner. So we'll start off with very easy problems, and like this example on SingPath that, write a function that, returns the multiplication of A times B. It returns the product. So I've given you most of it. You just have to know what goes here. And hopefully I've walked you along small enough steps that that's pretty easy to do. So we'll do that, and then we'll have like rankings, and some people want to move up their school ranking, and then they want to get into the Singapore ranking. I want to be top 25 Python developer in Singapore. And then eventually, if that's not enough for you and you're motivated, you can move on to the worldwide ranking, right? And then you're competing with people like Malcolm back there who can just, do everything in 20 minutes. Okay, so what I'll do is I'll let students go off and teach themselves Python. In fact, in my cloud computing course, I don't teach Python at all. They have to build things in Python, but I come in saying, you know what, you're all smart, you already know Java, Python's not that hard, you just go home and you teach yourself Python. If you have any questions, let me know, my door is open. And amazingly, no one comes and asks for my help with Python. They would rather just go ask questions on Stack Overflow, look at things on the web, and then I'll rarely have the student who comes in and says, I just don't quite understand this dictionary thing, I don't understand this list thing. But what I do then is I say, when you come into class on Monday, we're all going to have a short tournament. Very similar to what we're going to do tomorrow. And it's just a chance for you to see, how do you operate under pressure, right? Or how much did you really understand what you studied last night? So we'll have these short tournaments. People come in, and we have these rankings, right? And this can be intimidating to some, but don't worry, I only ever show the top 14. So if you come tomorrow and play, no one will see unless they go and scroll down. I'm not going to scroll down in front of everybody. But some people are awesome, and if you're awesome, I want you to get a chance to show off, right? I want you to have cool prizes that you can win. So tomorrow we have Lucasfilm. They've donated some cool Star Wars, swag, collector's merchandise. So if you're a fan, come. Just answer, 10, 20 problems as quickly as you can, and you might walk home with some really cool Star Wars stuff, right? And so you're awesome, you're developers, you should get rewarded for it. Now, one thing is, last year when I spoke at PyCon, I really focused a lot on individuals because I wanted people to learn at their own pace, at home. I wanted to give them lots of individual feedback. But that next stage is I want people to start getting used to learn together. I want some peer-based learning. I want people interacting. So in my software engineering course, we do all the projects as teams, right? So what we've started doing now is we don't just track who the top student is, we track who the top teams are, right? So in week 1, it might be whoever finishes first gets the Google t-shirt that Google donated to us, right? But the next week, it's Facebook gave us a backpack. The team that has 2 people finish first gets the backpack. And so then it's not about those 2 or 3 coders who are always faster than everybody else. It's who can mentor their teammate to get done first. And so here, if I was playing a tournament where the team with the top 2 people were doing the best, team 8 here would have won. And if I was giving the prize to the team with the best 3 people, then it looks like team 7 down here would have been in the lead. And so that's made it a lot more fun, and we get a lot more team dynamics. Okay, so the other thing that I've added since last year is now it's so easy to get started on the web. I'll start off in a class and I'll say, go through the Google Hello World App Engine exercise. Whether it's Java for my software engineering class or Python for my cloud computing class, find a partner, go through the lab. When you're done, just come over here and plug in your URL. I'll go check your URL and I'll give you some feedback. Did you do the assignment or did you not? So I have a whole path that's what I call the API path. You're effectively learning how to make a REST interface that returns JSON objects. And this is great, right? As soon as you can build a URL that when I pass you a get parameter, like name equals Chris, you return hello Chris. I respond, I pass you something like name equals Sandra, you respond back hello Sandra. Right? And this is great. Once again, I'm pushing bigger and bigger assignments off on students. They're giving them lots of feedback at their own pace, and they're sort of teaching themselves this faster than I could do it. This path has been fun because it turns out you can write it in Java, you can write it in Python, you can write your backend in Ruby, you can go off and write it in Node.js. I don't really care. I just care that you're going to give me a URL that when I pass you a get parameter or I post something to you, you can return back the JSON data that I'm looking for. All this runs on Python, running on Google App Engine. I like Google App Engine for me just because it's easy. It gets students started very quickly. It scales up. It scales down. It's self-provisioned, which means I don't have to go out and set up 30 accounts. Right now, if we were having a workshop, I could have all of you just go out and sign up on your own if you have a mobile phone number. And then you could be working through tutorials and just lets us move a lot more quickly. All right, and then the same way, once I have people doing the API path, I could just follow who's done more problems, and I can sort of keep track of how quickly the class is moving. But you don't have to have some fancy tool like SingPath or go do things really difficult like that. Sometimes you can just go make a Google Doc and make it public. Right? And then tell a group of people, hey, you can even do this like a hackathon or at a meetup. Just say, hey, as soon as your URL is working, as soon as your website's up, just come in here, type you and your partner's name down, put the URL to your app, and then we can all go click on it and see what you've done. And this is great if you're an instructor because it gives you feedback. You know, have 2 people finished, have 20 finished, because as soon as about half your class has gotten done, those people are going to be getting bored. They're ready for that next thing. So I like this. This is sort of real-time feedback for me. Okay, so this year for the software engineering course, what we did is we asked students to go out and create these games, all on Google App Engine. This was on the Java version of Google App Engine. And they had to create 3 games. You know, one that plays tic-tac-toe, one that plays Connect 4, and one that plays Gomuku. Anybody know what Gomuku is? No? Okay, it's like this big board. It's like Connect 5, right? But on a very big board, right? And so that was pretty straightforward, and that's something similar to what we normally do. And this is an example of what one of my teams came up with. You know, they clearly had a nice designer on the team. But the other thing I did is I said, while you're there, go create me this very simple RESTful JSON API that will let me check your app to see how you're doing. So I can get some feedback on how everybody's progressing and if anyone's struggling. And so I just created, it doesn't have to be pretty, I created this little URL. They could just go type their URL in. I would go hit it with a couple of tests, and it gave them this feedback of, here are the tests that you're passing, and here are the tests that you're failing. Right? So people had a clear goal to go after. But this is where it got fun, because now they had implemented this API where I could effectively pass them a tic-tac-toe board and get back their next move. Then every night when the students went to sleep, I could play all their games against each other. Right? Not for fun, just another opportunity to get feedback. So then when they came in, I could say, hey everyone, I played everyone's games against each other last night, and these are the total points per team. Right? So here's somewhere that they could click and figure out how much of the API they implement, but this is sort of like this relative feedback. And I say, you know, you're in the tournament, but it doesn't matter. Your grade has nothing to do with how well you do. At SMU, School of Information Systems at Singapore Management University, we don't teach artificial intelligence. We don't teach a lot of algorithms. But if you're interested in that stuff, knock yourself out. Right? And amazingly, a lot of students don't like to be in the bottom 10%. Right? And so what they'll do is they'll come and they'll click into a game and they'll go, why am I losing? Why am I so bad? And so this is Gomuku. They can come and see every single team I played them against and how they ranked. And so what this means is if it's a 1, it means the team over here won the game. If it's a -1, it means the player that moved second, they won the game. And of course 0.5 is a tie. Okay, so this is great. Now they have some more feedback, and they can start diving into whatever they're most interested in. And there's always like that one friend you have that's in another class, or maybe in your own class, and you really don't care about your ranking, but you want to do better than they do. Right? And I don't care. Whatever motivates you, knock yourself out. So like for tic-tac-toe, here's an example where you could click on the tie and see how did this tie take place. And just very simple GUIs, all running on App Engine, they can go through and see exactly how the game went through. And in the beginning, no students could play tic-tac-toe. Then everybody could play a valid game of tic-tac-toe. And then very quickly, people started saying, why am I losing at tic-tac-toe? No one should lose at tic-tac-toe. And so over the course of the term, I got to watch these ties, these 0.5s, just sort of spread until by the end of the term, like a 14-week term, no one was losing at tic-tac-toe. Right? That was like a badge of honor. It's like, how bad is your team if no one on your team can figure out how to make a never lose at tic-tac-toe algorithm? Right? And some of the algorithms, they weren't pretty. There was no recursion. There was no recursive. It was what's every single possible board that could take place. Someone did the math very quick, and it was a lookup table. And I was like, that's fine. lookup tables are very fast and efficient. And I think in the beginning, lookup tables were moving people up to the top, right? And if that gets you through tic-tac-toe, fine. Just enough code to move forward. All right, so a lot of good progress this year. Self-provisioning, everybody's getting into tools on their own. I'm not doing much work. Self-paced learning, go learn at home on your own pace. You don't need to wait on me to lecture. Peer-based learning, more team-based assignments. Open-ended learning, if you want to learn JavaScript, Ruby, other languages, we provided a way to do that. Lots of fast feedback, both team-based assignments and individual. But then when it came to this classroom efficiency, I realized where all my problems were happening were just on people's local systems. I can't get Eclipse to install. I can't get the Java version of App Engine working properly, or the Python version, or some library, or on my Linux system it works differently than on the Mac system. And that's sort of annoying because out of a class of 40 people, I'm always spending my time on like these 3 special children with their special, 2001 systems, or the little EPCs. It's amazing what people will bring to class. Okay, so the next thing is like I'm a cloud guy, right? So it's like I need to just do everything on the cloud. So how can I, get local system out of the equation? So I went off and found this site called CoderBuddy. Great website for what I'm doing. Pretty much it's like an online editor in the sky. You just log in with your Google ID, which everybody has if they're deploying to App Engine, and then you just edit your code. I mean, you just need to upload the Google Getting Started app or type it in line by line. And everything works online just as it would in your local development environment. All right? And so that really helped me with productivity, especially in those 3-day training classes where I walk in and I say, within 3 days, you're all leaving here with your own globally scalable Python app. Right? And this has sort of been one of those last tools that helps me move a little bit ahead. So that got everything moving really, really quickly. And the next thing I start to get is a lot of these questions. Like I'm throwing so much technology at people so quickly. We're moving very fast. And very valid questions. Why Python? Why JavaScript? Why Google App Engine? Why CoderBuddy? Right? And this is an actual quote I got. Why not learn something more serious like Java and an SQL database? Right? And to me, instinctively, I knew it's because we're going faster. You're learning so much. We're getting great learning outcomes. Can't you see how awesome this is? But they couldn't. So it's like, how do I better articulate why I'm choosing these tools and these platforms? So I finally got around to reading The Lean Startup. Has anybody in here read this book? Okay, this is a great book, easy read. I knew what Eric was all about. I knew about the Lean Startup movement, but I hadn't gotten around to reading the book. And as I read the book, Eric does a great job of explaining why you want to build these minimally viable products, why you want to go through this build, measure, learn type of loop, and why speed matters. Lots of great anecdotes. Won't go into it now. I could do a whole course just on Lean Startup. But it really is important that you can go really fast. And as you start to go really fast, new problems start to emerge. Like some for me, I thought that I was very lean. I thought I was going fast. And then I find out that there's things like continuous deployment, which means every time you develop a feature, you don't just test it and commit it back to GitHub or your repo, right? It's like every time you're done coding, you push it to production, right? So for me, pushing every week felt like I was being, quite aggressive. And then I'd have students tell me they push every day to production. I'm like, oh, wow, well, you're being a little crazy and wild. And then Amazon, one of the Amazon guys came and spoke at one of my courses this week, one of my 3-day cloud computing courses, and he said someone at Amazon is pushing live code to Amazon.com every 11.1 seconds. Right? Now, that's a very distributed service-oriented architecture, but every 11.1 seconds, new code is going up to Amazon.com. So to do that, you need new tools, right? If you're going to be deploying that quickly and doing really fast iterations, you're going to have to unit test and automate all your tests. Otherwise, you're either not going to test or you're going to have to manual test and it's going to really slow you down. Split testing, right? Rather than just kicking out features and hoping they're good and waiting to get around to a big usability test, you want to be sort of testing things on your users real time, right? So my next question was, could I teach things like unit tests, split testing, and do continuous deployment all in the cloud, all right? So the unit testing is pretty easy. There's something called GAE unit that you can just drop into your Google App Engine project, and it'll go to your test directory, and it'll run every standard Python unit test that you have. And the nice thing is it runs inside the GAE container, so you can access the data store, the task, all the same APIs you would use once you deploy to Google. So that's pretty straightforward. And then I worked with a friend in India, and we figured out how to get coverage working inside the container. And I don't know how you feel about coverage, but for me, I work with a lot of students, so it's just nice to know when my code base is getting away from me, right? Which file has more test coverage, which file has no test coverage that I should maybe be a little bit more concerned about. So me, I feel good when I'm like at about 50%. I know some people, it's like it should be 90% test coverage. For me, 5%'s bad, right? 50% feels like I'm probably going to catch most major issues that pop up. So the next thing is split testing. So split testing is pretty much, if you're 100 users are going to look at your page. When you come out with a new feature, you don't have to give all 100 users the new feature, right? Maybe you're changing some wording, changing a button, adding a button. Instead, you could just show that button to 10% of your users or 50% of your users, and then sit back and watch. Do more people do what I want them to do with this new change? If they do, great, let's make that the default. If they don't, then that's a bad idea, right? But in the past, if you just move everybody to new thing, you don't know if it was successful or not. All right, so in Python and on App Engine, this is really easy. This was written by the guys who make Khan Academy. So it's a pretty robust framework. It's this simple. You make a new test, give it some name. Here I've just called it simple test. And then down here it's if simple test is true, do one thing. If not, do another. In my example here, it's if it's true, you're going to make the background green. If it's false, you're going to make the background red. And with that just few simple lines of code, now the next 100 people who come to my site, half will have a red screen, half will have a green screen. Right? So that's very powerful. Once you have any kind of decent volume at your website, you can start doing real testing. All right. Then you get this nice dashboard that just gets generated for you automatically by GAE Bingo. And so if every time somebody does what you want them to do, like click on a button or click on a link, you just fire this one little method that says bingo, and it tracks it for you. And then eventually, you build up these statistically relevant results, and you go, OK, it turns out, let's say, that having the green screen is better. When you're happy with that, you just come over and click in this experiment, and then everybody will go to that path. Everybody will see the green screen. So that's that's something that we're working toward now with students. Rather than just having them build something and deploy it, it's like build it, deploy it, and then start measuring. So we can get people into that build, measure, learn loop a little bit quicker. All right, and then deployment, of course, if you're running on CoderBuddy and you're on App Engine, deployment's just a click away. You just click this publish to Google App Engine link, and then you see this nice little counter that says, I'm pushing your code up to App Engine, to whatever app ID you've set up. All right, I'm going to sort of skip over this a little bit because I'm a little short on time. But as I teach massive data analytics, my concern was how am I going to get lots of data into App Engine and lots of data out? Because a lot of times with App Engine, you have this 30-second constraint, or you've got to run things in the background. But it turns out the data store, you can just upload huge amounts of data to the blob store, and then download stuff from the blob store as big files as well. And it turns out the code to just upload files and then have a file loop back and download it back to you is just this. And so not that I'm going to go through this today, but it's not a lot of code, and it's something I actually have a prayer of explaining to people in a couple of hours. And then there's a nice demo application today that's for MapReduce. And effectively, they give you a starter app where you can upload a zip file and filled up with lots of text files. And then they'll go through and actually do sort of the hello world of MapReduce is go count all the words in a file. Or go create an index or find all the phrases that exist in a file. So that's pretty good because now I can start with an app like this, and all I have to ask students to do is upload a big file, maybe a CSV file or a zip file, and then ask them to make two simple functions, a mapper and a reducer. Right? So I've gotten a lot of the big complexity of setting up Hadoop, setting up Linux servers, all that. I just get to focus on the actual mapping and the reducing, which is pretty good for a shorter class. All right, so that's me. That's a little bit of a whirlwind of what I'm up to. I'm very interested in making education more fun and making training more efficient. So if that's something you're interested in as well, feel free to follow up with me. And with that, I will take questions. Yes?
framework that you've built been able to be extended to other coursework outside of computer science? Because the problem in education is computer science isn't the only thing that moves this quickly.
Mm-hmm.
And I'm thinking like, other hard sciences, physics, math. Is there a way to get students to compete against each other in intra-physics classes, intra-chemistry classes? Have you thought about that?
Yeah, so I actually have a general teaching methodology I call tournament-based teaching. And this whole idea of giving pre-class work, giving a quiz when class starts, and then doing group assignments. The Duquesne U.S. Medical School here has something called Team Lead, which is they actually teach medical students in a very similar manner. Right? For them, it's a lot more multiple choice as individuals, and then you get together as a team and you answer similar multiple choice questions. But as a team, you have to argue about it, and both count toward your grade, so you end up achieving sort of better agreement and more accurate results. One of the things I'm looking at now that sort of creeps out of the computer science space is statistics. So since as I do big data analytics, the code's not the hard part. Explaining statistics, statistical relevance, correlation, regression, that ends up being the harder subject. So I am experimenting with how to have statistics competitions. Boy, doesn't that sound boring, right? But statistics competitions, economics competitions are on the horizon. Yeah. Yes?
I think in your talk abstract, there was a mention of PyCloud. How do you use it in your work?
So PyCloud, when I saw them at PyCon in the US this year, they have this idea they're going to give everybody a supercomputer, right? So everybody has these free tiers. They're going to give you this, whatever it is, thousands of hours that you as a scientist can go work on problems. And their idea is if they make it easy enough and convenient enough for you, once you're spending that first 1,000 hours, well, then when it comes time that you need 10,000 hours, you'll be very happy to pay them, right? And they'll probably charge you the same per hour as you would have to buy an Amazon instance on your own. I haven't figured out how to use them completely in the cloud yet, which is one reason they didn't make it into this presentation. To do my PyCloud stuff, it's still go to your system, install PyCloud, add these 2 lines of Python, and then the way it works is whatever you run locally, then you can run that on their cloud as well. And they're marshaling all the data and the code back and forth for you. Another question. Yes?
This just maybe a bit off topic. I see that the ThinkPath, the website is continually developed. I think it's very nice. Have you got any plan to expand its functionality?
So right now, just we have like more users show up to ThinkPath every day. People always come in, and I'll get a support question or 2 each week. It's globally available now, and like I've held tournaments a couple of different places around the world. The general plan there is I don't really want to grow any faster than I can handle the support questions, right? As long as I've got 2 or 3 people complaining, a week, that's about the right amount. When all of a sudden nobody has any complaints, then it'll be like, okay, I'll go blog or I'll go tweet about something, and then that'll generate more questions. But no, if anybody's free, it's free service, anybody can use it. I mean, Sandra's passion for ThinkPath is just that anyone anywhere in the world that wants to learn Python, or more accurately, practice Python, practice their JavaScript, they can whenever they want, however much they want. Yeah. One more question? All right, I'll be around all weekend. Feel free to come up and chat. Love to meet you. Thanks.